Welcome everybody to the next pitch session. And in this session we will talk about modeling and economics. And the first speaker is Francisco Pereira, who is our new professor in smart mobility and ITS. And I think actually his presentation will nicely bridge the last session on innovation with this session on modeling, because I think he is covering both the areas. Francisco has a background from MIT and moved here last year. Welcome to you.
Thank you.
Oh. There's no microphone. That's... Hvad? No. Huh?
Yeah. Which one? Which button?
No.
Fint.
Thank you.
Okay, thanks. So, thanks Otto for your introduction. Yeah, I'm a researcher from DTU, previously DTU Transport, and now Transport DTU. My background is machine learning and transport engineering, so I do combine the two worlds. I've been working on these two areas for quite a few years. And my goal here is to create this lab that I call Smart Mobility Lab, that I'm going to talk about. This is an initiative that I hope will be central to Transport DTU, and actually should be interdepartmental. So this pitch is also an invitation for other collaboration around DTU, not just the sort of traditional DTU transport team, but also everyone else around, and also, of course, the industry and public sector. So, what's the best way to explain what I do than giving a few examples? So, as Otto mentioned, I come from MIT. I did a lot of work there, and I'm still involved in a few, so I'm going to mention a few of these projects. Some relate to the MIT, some I started here in DTU. The first one is autonomous vehicle modeling and simulation. So this is about a simulation model. It's an agent-based model where we simulate the impacts of autonomous vehicles. This is a project that we developed in Singapore. So in that particular case, the idea is to simulate a policy where a certain area, the central business district in Singapore, only has autonomous vehicles in public transport. This is in a poster. So by the way, everything with a P there is in the poster session, so I'll be happy to give you more details there. The second one is also research that started in Singapore, is also running here. That is about demand forecasting for large events like concerts or sports games and so on. So this is essentially applying machine learning techniques and web mining and text mining to predict demand for those events. Something I'm starting here is demand forecasting for shared modes. So basically the problem of for example, balancing in bike sharing. So whenever you have a bike sharing services, you know that you have to consistently rebalance the bikes. And the same issue I assume will happen with Drive Now, so I want to work on that kind of problem. Another one that is a project that I developed in Singapore is a smartphone-based travel surveys. So it's kind of a travel diary technology using smartphones. Another one that is starting here is a real-time traffic anomaly detection. So basically it's a project that we have here with Google that basically analyzes Google real-time feeds and detects whether there's a certain anomaly and applies web mining to explain them automatically. Another one that is also running project with MIT is multimodal real-time prediction. It's an agent-based dynamic traffic assignment model, so it's basically a simulation tool. And finally, I'm also involved in behavioral nudging. So basically, how to use information systems to help or to nudge people from you know, for example, private car to more sustainable modes like public transport. So thank you, and I'll be at the posters.
Thank you very much. And I have a small DCU puzzle for you here. So the next speaker will be Mogens Foskerau, who is a professor in transport economics. Welcome to you.
Thank you. Go ahead. Now it's on. Okay. I have 3 minutes to bore you with transportation economics. I chose not to have any pictures or any colors, just to make a good start. Maybe the main point is that here at DTU, we're not all descendants of Ørsted. We have social science as well. From the perspective of DTUs, maybe small, but from the perspective of our fields, we can be pretty important still. So we have a group on transportation economics, which is a branch of microeconomics. It has to do with time, space, and travel, so basically. And all that we do is somehow aimed at informing transport policy. So so the aim is to analyze policies, which can be investment, regulation, pricing, anything that's politically decided, predict what's going to happen, and evaluate the welfare consequences of that. Some areas that we've been working on a lot one is valuation. So to evaluate projects, we need to know what's the value of time, what's the value of reliability, what's the value of frequency. So things you cannot buy, but that we prioritize when making transport policy. Another big area is the relation between transport issues and urban issues. So the transport system, of course, that's why it's there, interacts with the urban system. So it has impacts on where people live, where they work, where we can have production, and so on. So we are branching out into this intersection between transport and urban economics. We have a lot about congestion. At the moment, we are getting access to Google data, and we want to know whether we have hypercongestion in Denmark. And you can see what that is at the poster session, and so on, many other things. A very important thing for the group is that we advise the Ministry of Transport on how to do welfare economic assessment of transport policy, cost-benefit analysis. And as we've been doing that for 15 years now, more or less. There's a manual with guidelines for how to do this that's used for all projects at the government level in transport in Denmark. And that's, in many ways, we can think of that as an end user of our research. In the end, this is an important way in which what we do is used to inform policy. Finally, I want to mention a bit about the impact, and we have and the institutions that we work with. Of course, the Ministry of Transport and Building. We have a large project at the moment for the Innovation Fund. We have had projects for the Danish Research Councils. We have partners in projects including the Danish Industry, Krax Fund, Urban Europe. And in terms of research, we work with more or less everybody around the world in transportation economics. And we publish in economics, transportation, urban economics, public economics, and so on, and now even in physics.
Thank you very much. And you get one else. The next speaker is Elisabeth Kashi, who will talk about transport behavior research. Kashi, sorry. You can use this one. Okay. It's working now? Okay.
I'm not that used to use microphone, but Transport behavior research means many things, and I mean, it seems that it is an area that merges psychologists, sociologists, behavioral economics, and I'm an engineer. Actually, I'm a civil engineer, but when we talk about all these transport modes, you have heard about railway, maritime, whatever, electric vehicles, etc. But who is using this system? Individuals. So basically, to understand how people use or can use this system, we need to understand how people take a decision. So think about a very key question in transport problems. Very simple one. How many buses do we need between no report and here? We need to answer. How many parking slots, for example, in the airport? How many charging stations if we want to go, for example, with electric vehicles from Malmö to Hamburg? Or even a little bit more complicated question, like which characteristics should have electric vehicles if we want to reach the target of 50% electric vehicles by 2020, something like that. Or how do we motivate people to shift towards sustainable mobility? We heard that transport accounts for 40–50% of pollution, so it's important that there is a shift in the way people move toward the current way into more sustainable modes. Or how will the different segments of the population react when we change the transport system? So it's very difficult to answer this question, but it seems quite different, quite different question, but they have a common ground, which is we need to know what is the demand. We need to know how many people will use that system with that characteristics. And more than that, we need to know what are the factors that explain and affect the choice that we make every day. When we decide to go to work, when we decide to come here to the kickoff meeting, we decide what time to come, which mode, with whom, etc., etc. But also higher level question, like we decide where to live, and this affects the way we move. So all these questions, every time there is people involved that take decision, we need to know the behavioral process that leads people and need to make some choices. And I think there is another slide, is not coming? Okay. So it's more important what we need to know is the overall demand is as a result of the sum of the choice of each individual. So we need to understand, first we need to understand, we need to model, because behind that there is mathematical models that allows us to link individuals and the choice with the characteristics of the individuals, the society, and the transport system. So the goal of the transport research group is to better understand, better model, better forecast, better advise administrator on how to model and simulate the demand that use different transport systems. Thanks so much. And there are very good posters, 2 posters, if you want to know all the application we have and more in detail how we can calculate these things. Thanks so much.
Thank you very much. Then I will welcome the next speaker, Paul Hjort, who will talk about modeling of pedestrian flows. Here it is.
Yes, good afternoon. My name is Paul Hjort. I'm with the DTU Compute section on dynamical systems. So transport of crowds, ensuring an efficient and safe movement of pedestrians through the built environment is a very important but also very challenging modeling task. So on the leftmost picture, you see the top level, the crowds that we have to deal with. You find them everywhere in metro stations, in sports stadiums, at outdoor concerts, and so on. And when I say we want to have an efficient movement of crowds, we want, of course, to avoid congestion. Everybody wants to get from A to B as quickly as possible. When I say safe, I mean to avoid congestions, which sometimes in crowds, as we all know, as the survivors tell us, can be a very crushing experience. And this is definitely something which is still a bit of a mystery and very much in need of modeling. So people have tried to model this in various ways. To the fluid mechanicist, a crowd is a complex, viscous fluid. To algorithm people, some have tried to model it as cellular automata, but I think the majority of current models for crowds is an agent-based model, and this is also what we are doing currently in Section for Dynamical Systems. But there is a tendency with these models to be a little bit ad hoc. You set up a scenario, you tune some parameters until everything looks okay, and then you have a simulation that corresponds somewhat with reality. The problem is that if you now shift these walls, if you change the built environment, your model will tend to fall apart, and somehow the parameters don't fit anymore. So we are currently looking, and this is the last level, we are looking for mathematics which is able to describe in a sufficiently robust way the motion of crowds, so that you can actually, from pretty much first principles, model various scenarios and get away from having to do a new simulation or even live tests, which we also do, and we know this is very tricky, for every building, for every metro station, for every stadium that you build. So this is our noble aim, and we are continuing to work hard towards that aim. That is my pitch. Thank you.
Thank you very much. And now we will continue with the next pitch, which is Sune Lehmann, who will talk about sensible DTU.
Yep. Should I press a button?
Yeah.
There we go. All right. So I am doing research in transportation by accident. I am actually interested in how people form networks and how those networks develop in time. So what I did was that I bought 1,000 cell phones and I handed them out to all the first-year students here at DTU to collect information on who is close to each other, also who makes phone calls to each other, and also who are friends on Facebook and so on, and basically focus on the social. But it turns out that where you meet, of course, is also important. If you meet on campus, it has a different significance than if you meet at someone's place where they live, which has a different significance than if you meet at a bar or something like that. So we also collected the GPS traces of these 1,000 students, and we collected them over a couple of years. And here you can see some of the transitions they made, and you can see how they move around Copenhagen and effectively measure a lot, lets us know a lot about how people use Copenhagen, and also all around Denmark, and also all around the world. And the data set we have is really interesting for transportation because we sample how they move around at a fixed rate. So that means that every 5 minutes we have a recording, and a lot of what we know currently about sort of how people move at large scales has to do with data collected from cell phones and moving around cell towers. So one of the projects we do now with a group from MIT is basically understanding what kind of biases are introduced in the sampling of human mobility by using information from cell towers. And how that affects, for example, how we can predict things. We also have these very long traces over we collected data for almost 3 years. So we also have some sort of new insights into how people's mobility patterns change over time. So if we take one person, try to model that person, how does their sort of habits change over time? And I hope, I'm not sure, but sort of these insights I hope can fuel better models for transport prediction and so on. So that's more or less what we do on transportation in my group. So thank you for your time.
Thank you very much. Now we will go to the next pitch, which is Marie Münster, who will talk about the COMET project.
Hi. Oh, thanks. So my name is Marie Münster. I'm a senior researcher at DTU Management Engineering. and I come from the system analysis group, where we have the luck that the transport economic group has recently joined us, and they're supplementing our group in energy economics, so that's quite relevant. So I come from the energy systems analysis group, and normally we analyze energy systems and provision of electricity and heat and so on. We've done scenario analysis of that. Normally we look at national systems, and we've found that we have a good understanding of how we can have 100% renewable energy systems in the future. The next challenge is transport. So we're starting to look into that. This is a project we have which is called Co-Management of Energy and Transport Systems. It's running until 2019. And what I wanted to say is that what we're doing is we're looking at the integration of transport together with the energy system. This goes for example, when we have biorefineries producing heat we can utilize in the energy system, or consuming electricity at smart times for the transport sector. And normally when we do our energy system models, we do cost optimization, assuming that our actors are economically rational. And I don't think that's as good an approach in transport as it is in energy, where we have big-sized utilities actually making a lot of economic analysis before they make their decisions. Now we have all these people making transport decisions, and the one step we'll go first is to try to integrate some of this non-rational behavior by looking at travel time budgets. So we have 2 posters on this project, which is out in the project tent. We have a similar project looking at the Nordics, where we are having a similar approach. And then we have projects where we're looking at the gas sector. What will the role of the gas sector be in the future? And how much gas are we going to use for transport? So we're also taking all the time from the energy system perspective, but more and more looking into the transport sector. Yeah, I think that was my pitch.
Thank you very much. And then we will go to the last pitch, which is Bjarne Ersbøl, who will talk about big data and statistics.
Oops. Okay, thank you, Bjarne Ersbøl. On the 7th of November 2011, an IC4 train missed a red stop sign by about 651 meters and was close to banging into the end of a freight train, and that was considered quite an accident, and it grounded the IC4 train for some months. And as Otto Unger mentioned, the IC4 train's brakes were questioned, and DTU made this investigation, which showed that it was not the brakes that were the problem. The problem was most probably low adhesion, or slippery tracks, as it's called in more popular or colloquial language. So after the IC4 projects with the brakes, we were allowed to have a look at what causes slippery tracks. And here we have the 4 different V's of big data, as they often are mentioned. Volume, do we have volume here? Oh, not necessarily. Velocity, do we have velocity? Is there any problem here? No, we don't really have velocity of data. But we do have 2 other things, and that is variety and veracity. So here we are collecting a large variety of different data that come from different stakeholders, which is posing a problem. And this is a big data problem. It's not a technological problem per se, but it is sort of a change of mindset. You have to dare to give me your data. I have to dare to give you my data. And together we will lift this problem, and we will pick the low-hanging fruit and be able to do something extra for the transport sector. And if you want to hear more about this project on low adhesion, then I'll be out in the tent in just a few minutes. So it's about combining data from the train computer, from RailNet Denmark, from DMRI, that is the Met department in Denmark, and trying to work out what is actually causing the low adhesion. Thank you.
Thank you very much.